The sun, the nearest star to Earth, and by far the most important source of energy for life. This is the sun as it appears in visible light spectrum, with a filter to reduce the intensity of sunlight. The color of the sun is white, but it appears yellow, orange, or red through Earth's atmosphere due to atmospheric Rayleigh scattering. This disk is called the photosphere, which is the visible surface of the sun that we are most familiar with. Matter can exist in 4 states: solid, liquid, gaseous, or plasma.
Plasma is formed when a gas is heated to an extremely high temperature or subjected to strong electromagnetic fields, causing the atoms to lose electrons and become ions. The sun is made of plasma. Plasma easily conducts electricity, allowing it to move along invisible pathways charted by the electromagnetic fields that fill space. The areas that appear dark on the surface of the sun are called sunspots. The sunspots appear darker because they are dimmer and cooler than their surroundings. The sunspot's center is about 3,480 degrees Celsius, but the surrounding photosphere is about 5,530 degrees Celsius. This is how a sunspot is formed. The energy deep inside the sun is transferred from the convective zone to the surface through convective currents. The hot plasma rises toward the surface, loses its heat to the cooler surface, and then sinks back down to be reheated. However, when concentrations of a magnetic field from deep within the sun reach up to the surface, they inhibit the convective currents, preventing the hot plasma from reaching the surface. This creates a cooler area in the photosphere, which appears darker than its surroundings. A sunspot. The sunspot's number varies according to the solar cycle, and they may last anywhere from a few days to a few months, but eventually decay. A closer look at the surface reveals patterns of light areas surrounded by darker borders, called granules. Granules are small cellular features that cover the entire surface of the sun except the sunspots. A typical granule is about 1,000 kilometers across. Granules are convection cells created by the heat rising to the photosphere from the hotter solar interior. When the hot, rising plasma reach the surface, we see bright areas. The darker boundaries of the granule are places where the plasma has cooled and is sinking back into the sun's interior. In order to see the next layer above the photosphere, we need to switch imaging from visible spectrum to extreme ultraviolet, precisely at a wavelength of 30 nanometers. The chromosphere is an irregular layer above the photosphere where the temperature rises from 6,000 degrees Celsius to about 20,000 degrees Celsius. At these higher temperatures, hydrogen emits light that gives off a reddish color. This is what gives this layer its name, chromosphere, which means sphere of color. The chromosphere is normally hidden from our view. Its light is much weaker than the brighter photosphere. However, it can be seen at the very edge of the sun during a total solar eclipse. The corona, the outermost part of the sun's atmosphere, which is usually hidden by the bright light of the sun's surface. That makes it difficult to see without using special instruments. The corona can be viewed during a total solar eclipse. The temperature of the sun's corona varies, typically ranging from 1 million to 3 million degrees Celsius. These layers form the sun's atmosphere, and each layer varies in thickness. The photosphere is about 400 kilometers thick, and the chromosphere is 1,700 kilometers. The transition region is about 100 kilometers thick. The corona extends millions of kilometers into space. Its thickness isn't fixed. It varies depending on solar activity, such as solar flares and coronal mass ejections. The sun's atmosphere has many features, such as solar prominences. A prominence or filament is a large, bright feature, extending outward from the sun's surface in the photosphere, through the chromosphere, and into the corona. The red glowing looped material is plasma, a hot gas comprised of electrically charged hydrogen and helium. The prominence plasma flows along a tangled and twisted structure of magnetic fields generated by the sun's internal dynamo. An erupting prominence occurs when such a structure becomes unstable and bursts outward, releasing the plasma. Prominences can be viewed during a total solar eclipse. Scientists are still researching how and why prominences are formed. Scientists are still researching how and why prominences are formed. The magnetic field lines, usually near the sunspots, often tangle, cross, and reorganize, causing a flash of very bright light known as a solar flare. A solar flare is a sudden explosion of energy that releases an intense burst of radiation, including X-rays, gamma rays, radio waves, ultraviolet, and visible light. And if a flare is very intense, it can interfere with radio communications on Earth. The occurrence of solar flares varies according to the 11-year solar cycle. Solar flares are the most powerful explosions in the solar system. The biggest ones can have as much energy as 1 billion hydrogen bombs. When the sun's magnetic field lines tangle, cross, and reorganize, it can result in a solar flare, which is typically accompanied by a large coronal mass ejection, or CME. Coronal mass ejections are explosive accelerations of plasma away from the sun. What you see is a very large coronal mass ejection, with much of the ejected material being cooler and therefore appearing dark against the brighter solar disk. Material that does not reach solar escape velocity can be seen falling back and striking the solar surface. Enormous coronal mass ejections are capable of reaching and colliding with Earth's magnetosphere, where they can cause geomagnetic storms, aurora, and in rare cases, damage to electrical power grids. Coronal rain refers to the phenomenon where cool, dense plasma falls back into the sun's surface, forming giant arches of plasma. The electrically charged plasma is attracted to the magnetic fields and outlines them very clearly as it slowly falls back to the solar surface. Looking at the edge of the sun, we can see jet-like eruptions. These are called solar spicules. Switching to hydrogen alpha imaging reveals that they resemble blades of grass or hair. Spicules are dynamic, short-lived, and highly energetic jets of plasma that rise from the sun's surface into the solar atmosphere. They are characterized by their narrow, elongated shape and may extend up to 10,000 kilometers in height. Spicules erupt at a very high speed and last for about 15 minutes.